Good afternoon, everyone. My name is Pedreira. I'm a software engineer at Meta, and I'm going to be here giving a sponsor talk. There are many things we could be talking about, but we're going to be focusing on Velox, which is one of the new projects we have that got a little momentum recently, and we think it's pretty cool. So we're going to focus on this project for two reasons. The first one is because, well, we want people to learn more about the project. And like I said, we think it's a really interesting piece of technology. But the second part is that it's an open source project that we're really looking for collaborations. Right? So if you're a student, you're just thinking about helping other cool database projects, or if you're a professor, if you're looking for collaborations, if you're in the industry and you want to use this or help develop, please reach out. So first, I'm just going to focus a little bit on the motivation, like why did we start this project? We have a huge workload variety at Meta, so we have users trying to use database systems and data management systems more generally to do all sorts of things from analytics. And when you talk about analytics, it's both kind of batch ETL processing, but also interactive analytics, things like real-time processing, like we've been talking about graphs, so we have lots of workloads around that. There's many monitoring systems, transactional systems, and more recently, there is a bunch of systems that have been developed for ML workloads. So I think the gist here is that there's a lot of workload variety, and this thing is changing, right? So right now, ML is the new thing, but have with good confidence that in the next 5 or 10 years, we're going to have new workloads, and we have to adapt and change our systems again. So this thing is always changing. It's kind of a moving target. Usually the usual answer for those things is to specialize engines. So every time you talk to new users, they have a slightly different use case. We just go ahead and we implement a full new engine. This is just, of course, like a small subset of things we use inside Meta. If you look at the industry, like this table, we'll get easily to hundreds of different engines, right? So like every time you have a new engine, you just go ahead and you specialize and you create a brand new engine, which has a brand new implementation of pretty much everything. With engine specialization is that there is usually very little reusability, if at all, between systems. It really duplicates our effort. So every time you start a new database, you need to not just implement the thing you're actually changing, but you need to implement everything else, from storage management to all sorts of indices, to even the function packages. So it's really hard, and it forces us to keep reinventing the wheel. But even after that, it's really hard to maintain and to enhance. Right? So if you're actually a large company and you need to maintain 20 different database systems, if you need to optimize something, or if you need to add a new feature somewhere, how do you decide where you do that? And you just end up doing that 10 to 20 different times. And what's even worse is that usually those incompatibilities and those inconsistencies, they bubble up to end users. So if you're a user interacting with many different database systems, they all offer different SQL dialects. They're all incompatible between each other. They work in different ways. They provide different function packages. So it's really hard for a user to be efficient across different systems in a stack. And overall, it just hurts our capacity to innovate and move fast because we keep re-implementing the same thing over and over. The good news is that if you look at those engines kind of through a looking glass, they all compose more or less of the same sort of logical layers. All of them have some sort of language layer that takes an input from a user, generates a logical plan or a physical plan that goes through an optimizer. You generate, query plan again, an IR goes through an optimizer. And at the end of the day, this gets distributed, and there's an execution engine that ends up actually executing those operations. So if you look at all those different engines, here's just a few examples we have inside Meta, but every single database engine can be kind of decomposed in those sort of layers. They're sometimes not exactly the same. The APIs in between those components are vastly incompatible, but they're all composed of those layers. And the observation for Velox is that if you look specifically at the execution engine of all those databases, even though they do very different things, they're actually very similar. So if you look at how you evaluate expressions in an analytic database like Presto, and how people do that for ML training, that's actually very similar. Just they're implemented by different people, they're maintained by different people, but there's no reason why they need to be fragmented and kind of duplicated. As like I mentioned, so Velox is essentially, let's look at all the execution engine across all those different systems. Let's actually find the commonality between those things, and let's factor it out as a library so we can maintain that once. Just a cool logo. So the mission is just to converge, accelerate, and unify execution across Meta and beyond. And this part of and beyond is because we believe that this is actually a large enough project that we need to tackle as a community. So of course, it's already open source, and we're really extending the community and looking for more partnerships. So we say that Velox is a database acceleration library. We provide generic APIs that you can reuse when building engines across use cases, from batch to interactive, to stream processing, to monitoring, to time series processing, to all sorts of AI, ML workloads. There are two key concepts. One is modularity. So even though those things are similar, the granularity in which you need those operations are different. So for instance, for ML training pre-proc, you usually just care about expression evaluation, while for like a SQL engine, you would care about not just expression evaluation, but joins and all sorts of SQL operations. But the idea is providing those in different layers of granularity. And the second part is extensibility. So even though there's commonality, every single engine has some particular operations or some specific operators or specific data types. So all the libraries developed with extensibility in mind, so that users can actually, or developers can actually add any specialized behavior. Of course, everything was developed in C++. Like we spent a lot of time benchmarking and seeing how far we could go with Java versus C++. And we like to think that Velox is a state of art. So what we do is, as we integrate this with other different engines, we really partner with other developers developing those tools, and we try to centralize all those optimizations. So in a way, we like to say that we democratize those optimizations. We centralize them in a single library, and then you multiply the impact because we use that everywhere. So Velox is a database acceleration library, and that's very different from being a full DBMS. So Velox only takes a physical query plan. So there's no SQL front end, there's no parser, there's no global optimizer. We don't have any optimizer, but we do leverage adaptivity, which you can think is more like runtime optimizations that you can do while you process your data. But having an actual full-blown distributed optimizer is something that is outside of the scope of Velox. So just moving a little faster, there are three main value propositions. One is just efficiency and latency. Second one is the idea that if you use the same execution library across different engines, it actually provides a more consistent experience to end users. And the idea of usability, if you implement an optimization once, it's available in all the other engines. If you're developing new engines, you don't need to write the execution from scratch, you can reuse it. That's another strong reason why we develop this. I'm not going to list all the use cases, but just so we have an idea of the breadth. So we're integrating with analytics systems like Presto and Spark, but we're also using Velox and real-time infrastructure. So the stream processing system is already built on top of Velox. It's also integrated on the database and data warehouse ingestion system. So as you actually ingest this data on the warehouse, you can do some transformations, and then you use Velox to do that. It's even being integrated with transactional systems. And here there's a whole lot of discussions between trade-offs of vectorization and code gen that deserve a single talk by itself. But it's also being integrated, and we're making heavy use of that in machine learning on all sorts of use cases, from training, pre-processing, from both serving in inference and training, but also for feature engineering. We open source here. There's just a few links. There's this. If you want to get some more of the technical details, please follow up on our VLDB paper or reach out. Everything is available on GitHub. We have a very vibrant community. Last time I checked, we had something like almost 200 developers. So the community is really picking up, and we're partnering with a lot of companies already. Just kind of a quick list of things we provide, from type definitions to columnar data, memory layout, expression evaluation, APIs where people can develop scalar and aggregate functions, operators, a bunch of APIs to extend and to implement I/O from the actual file system, file system API to APIs where you can implement different file formats, two things you can use to help resource management. Just so I think it's just my last slide, just a few things we're working on. And those are really things that we would like to collaborate. So if anyone has ideas, or if you guys are interested in any of those topics, please reach out. So the first is this idea of actually keep blurring the boundaries between analytics and ML. So if you look at those things, the boundaries between things you do on top of Arrow and columnar data sets and SQL engines versus things which are done on top of tensors and the PyTorch world, it just seems rather arbitrary. So the more we look at those things, the more it just seems that they're different because they're implemented by different people. So there's a lot of discussions on how can we implement, or how can we optimize those workflows, and how can we better integrate those two worlds. Right? So that's one of the things we're doing with Velox, but it's one of the things that there's still a lot of work to be done, and we really care about this. Second one was something that Gustavo mentioned this morning. We think that there's a very powerful opportunity here as with Velox. If you see Velox as this idea of converging execution from all the different engines in a single library, you have a single place where you can ensure that any types of hardware already fully leverage accelerators. So that's one way you can address, maybe even going back to Peter's question about how do we handle complexity. At least if we have this implementation just once in one library and we can reuse in all the different engines, that's something that provides a really powerful model. So we're really looking at how can we make sure that Velox can fully leverage the hardware we have available, being it accelerators, being it RDMA, OpenCXL, or whatever types of new and fancy hardware. The other thing is just here we're componentizing the execution engine of data management systems, but we also believe that the other components can also be more modular. So we actually have a talk tomorrow. We're going to cover a little bit more about this, where Velox is one of the ideas around componentization, but we actually have a lot more. And I think here is just what I was mentioning. We're really looking for more collaborations. So if anyone is interested in the project, or if you have ideas of other cool things we could add to Velox, please reach out. We're really looking for collaborations. And here's just a plug. So we have another paper presentation tomorrow where we're going to cover a little more holistic view about all the efforts around componentization. Like Velox is one of them, but there's a lot more. That's everything I had. Thank you guys for bearing with me. Not sure if we have a space for questions, but I'll be happy.
Of course, we have space, and thank you so much.